Um, this is a long time coming, so let's get down to this with chapter 7. Um, Water and electrolytes. All right, water balance, electrolyte balance, trying to figure out what we need. So this is something that we went over in the first nutrition class. We went over the basics of water and electrolytes, everything like that. But this is going to be more of the application component of it. So we'll get through some of the nuts and bolts, and then we'll move on and move forward with each specific section as to how it relates to trying to maintain proper hydration status for like for this whole course that it's been exercisers and sport performers. All right. So when we talk about fluid, okay, um, you know, there's always this whole mentality that there's the 3-day rule where you can go more than 3 days without food, but you can't go more than 3 days without fluid. So that's hence the reason why the first thing is here on water is the most important nutrient. Well, yeah, I mean there isn't any. Let's be really clear about this. Water doesn't have like any caloric value to it really, but ultimately it's important because of the fact that it provides our body with a way to function correctly. All right. Uh, that's an average number. About 60% of your body is water. Obviously, everybody has a little bit different amounts. Some have lower, some have higher. Okay. Um, with we'll get into this a little bit later, but with higher amounts of water loss, you're talking about performance declines and then obviously health concerns as you start losing more and more. Okay. Electrolyte balance, particularly sodium and potassium, are going to be really critical for that. Okay. There has to be an individualized. Wow, there has to be an individualized plan for each specific person. Exercise or athlete doesn't really matter. All right, and the reason for that is because there's many factors besides just what are they doing, okay, or how hot is it outside. Okay, there needs to be specifics for that, and like I said, we'll get into that a little bit later because the plan is going to be more important because each one of us, it's like, oh well, yeah, you're supposed to have 8 cups a day. Well, that's false because, well, I'm not saying it's 100% false, but it's false to an extent that not everybody is going to be okay with that. All right. So now, as we go through everything here, you're gonna see these terms pop up a little bit more. You're gonna talk about euhydration, hyperhydration, and hypohydration. Now, just like hypo is very, and then U is consistent across many courses we've had. Euhydration means proper hydration. It's the adequate hydration that your body needs to make sure that you are hydrated. Okay. Hyperhydration, that just means that it's hydration over what your normal status is. All right, and then hypo is below. Now, normally we refer to everything as dehydration. Well, the book, your book for this class, um, basically talks about how like dehydration and hypohydration they're kind of like synonymous. They're kind of like they kind of throw each other around and loosely, and that's a problem because dehydration is the act of losing fluid. Okay, hypohydration is what most people consider to be dehydrated. Okay, so if you are dehydrating, that just means you are losing fluid. Okay, so let's just be clear on that in terms of terminology purposes. Okay, so that's going to be very critical for us to understand is that we've been kind of bred to say regular proper hydration and dehydration. Well, no, just remember dehydration is that moment of losing fluid, where hypohydration would have been the right terminology for that. Okay, just kind of like an overview there, just to kind of make you understand what we're going to be getting into here. So, first step, just talking about electrolytes for our sake. There's there's 8 different things that we have in this whole in terms of this whole electrolyte component. But what we look at is what are our positively charged and what are our negatively charged. So our cations are positively charged, our anions are negatively charged. The ones that we spend a lot of time with are typically, sodium, potassium, chloride, and phosphorus. But those are like 4 of the majors. That doesn't mean that calcium, magnesium, bicarbonate. Okay, all of those mean something, and we need those because we have to have proper fluid balance. Well, get yourself too positive, charged, and it can change your osmolarity. It can change your pH balance, and that can change hydration status. Get yourself too negative, same thing. Okay, so just something to kind of be aware of in terms of that. So, with our electrolytes and positive balance, negative balance, all of that good stuff. What are we looking at here? What is it that we really need to pay attention to? And that's really, how much water do you need? How much fluid do you need? Because it's not always going to have to be. But it's going to be, what are the factors that make it up? Well, obviously we know body size. Okay, if you're a larger person, and that doesn't mean larger like bigger or not to be rude, but that doesn't mean if you're bigger in terms of fatter. It doesn't mean if you're more muscular. If it's just a larger person in general, someone who is bigger needs more water because they have more surface area that they have to contain. Gender, typically males have more body water, but that's typically for the fact that, number one, they are a little bit larger in terms of a person, but also number two, they carry around more muscle. More muscle carries around more fluid. Okay, age, as you age, you start to lose hydration status. So that's why it's always critical for the olders, to basically be able to, to stay hydrated, and it becomes a lot harder. Okay, but the younger you are, the more body water you have. But that doesn't mean that it's something you can write off and be like, oh, I'm younger, I don't need it. No, that's not the case. Body comp, we talked about leaner individuals have more body water, simply more muscle mass carries around more fluid. And then you can see, hence the gender difference. But look at the difference in terms of, this is just a 70 kilo male versus a 70 kilo female. And look at the difference between how much fluid that they carry around. All right, so it's a substantial difference, 12 liters difference, and that's just a lot of fluid. All right, but those are simple factors to understand. Those are things to kind of grasp onto. All right, so just kind of keep those in the back of your head. All right, also needing to understand here that we have different fluids. All right, we have intra and extracellular. All right. Extracellular fluid being plasma, and then the interstitial fluid, which is basically it's the fluid that's found between cells. Okay. Now, intracellular is exactly that. It's inside of the cell. But you can see here that our total body water is made predominantly of intracellular fluid, but extracellular fluid is going to be very critical for blood volume, for carrying, and when blood volume is down, carrying oxygen and nutrients is down. So you can see where it gets really tricky with that. All right. The book kind of gives you about, what do they say, about 2/3 intra and 1/3 extracellular. But yeah, so interstitial fluids, again, those fluids found between cells makes up about 80% of your fluid, whereas plasma makes up about 20% of that extracellular fluid. So, within this area down in here, the extracellular, majority of it is interstitial. Okay. So this kind of gives you an idea as to the breakdown of how everything works. So you're talking about 2/3 of that 70 kilo person, going back to, if we went back to the slide here, this bottom component, going back to the 42 liters that a 70 kilo male would take in. All right, if you look, we're talking about each one of these is a liter. So you're talking about 28 liters of the 42 liters of total body water that is made up of intracellular water. 14 liters, about the remaining third would be of extracellular. So drastic difference between the two. But it's pretty cool to see the visual, because it really makes you understand that, I think we take for granted how much fluid we actually carry around. Or I don't even know if take for granted would be the right word. We definitely underappreciate how much fluid is actually flowing through our bodies at one time. I mean, if you think about it, if you go to any gas station around here, 7-Eleven in particular, you go to the water section if you don't have water with you, and you go buy a liter of water, and usually 7-Eleven, they have buy one get one free sometimes, or 2 for $2.22 or whatever. Well, Those are liter bottles that you're buying. And so just think one of those is 33.8 ounces. So 1 liter is 33.8 ounces. Well, multiply 33.8 ounces, and now we're talking about a lot of, so we'll just kind of pull that up really quick. And so if we go to the calculator, so you got to figure, if you're looking at everything, you got 42 liters times 33.8 ounces, which makes up a liter. That's 1419, about 1420 ounces. Now divide that by 128, which is in a gallon. Basically, if you were to go and buy 11 gallons of milk and pour that into an empty body like you are, that's what you're basically carrying. So kind of a cool representation of that, you know. So that's just for simple conversions. That's not going to be like on a test or anything like that. But again, it's just a way for you to kind of understand. So yeah, again, 42 liters, which is over here. Follow the cursor. All right, 42 liters for that. That's for a 70 kilo person, which is 154 pounds. Male, by the way. And like I said, if it's 42 liters and we know that there's 33.8 per liter, that's just, like I said, that's about 14, just say 100, ounces. And then, there's 128 ounces in a gallon, and that's why I said it's 11 gallons. All right, so kind of a cool little thing there. All right, but just kind of put that into perspective. Now, this right here is basically showing you how electrolytes are dispersed through plasma, through interstitial fluids, and then through intracellular fluids. All right. Now, you can see that in typical extracellular fluid like interstitial fluid and plasma, majority of your electrolytes that are distributed throughout the body or throughout the extracellular fluid are, follow the cursor again here, Na. So we're talking about sodium. All right, so high levels of sodium in both interstitial and plasma, and you can see there's high levels of chloride in there as well. All right, so it's pretty it's pretty cool that that's what we're looking at there. So sodium and chloride. Intracellular fluid, particularly in skeletal muscle, you can see that there's a little bit of sodium, and that's particularly because within cells we have high levels of K or potassium. Okay, and then also there's high levels of phosphates in there as well. All right, but you have little amounts of sodium. Okay, so kind of cool. But this is just a typical breakdown. So, for our sake here, what are we looking at? Sodium being the more prevalent electrolyte within extracellular fluid, potassium being more intracellular fluid. But that's good because we know that we have sodium-potassium pumps, that we know that sodium is always more prevalent on the outside of a cell, and then when it comes into a cell, it wants to excite it, so that you get the interpretation there. So that makes a lot of sense with this breakdown. All right, and this right here goes into what we would call, these are different solutions talking about like isotonic or hypotonic, or hypo, hyper, and isotonic. Okay, so when we look at everything here, we're basically talking about how things move, and basically what I was just talking about, sodium, potassium kind of flowing through each other, but that's just one example. Right here, what we're talking about is if you have a concentration of something that is inside or outside of a cell, well, what are we going to have for movement? What's going to go in? What's going to go out? All right. So when we get to an isotonic state, and this is this first one right here, over here, when you get to this state, that basically means that everything is staying. Nothing's moving in, nothing's moving out. So, under resting conditions, things like that. All right. So nothing is going to cross over the cell membrane. The permeability doesn't really matter at that point. When you get over to the B, this B over here, extracellular fluid is hypertonic to intracellular fluid. What we're saying is that there is a greater, and if you look at the image up here, there's a greater concentration inside of the cell. So if there's in fluid movement, what we always talk about is moving from a higher to a lower concentration. So if the inside has a higher concentration, we're gonna send out content, or the solution is going to move its constituents to the outside, so inside to outside, and that's hypertonic. In a hypotonic state, what we would have is movement from the outside of the cell to the inside of the cell. That means the concentration is higher on the outside of the cell meaning it's going to allow for movement into the cell. And that's how we get things out, and that's how we get things in, and that's, again, with isotonic, that's how we get things to stay. Okay? So with all of that, we look at then water. How does, with loss, with intake, with balance, with imbalance, it's all about a lot of different factors that come into play for this. Okay. So when it comes to water gain, water loss, how are we gaining water? Well, we gain water through beverages, we gain from food, and then we gain it from the breakdown of our metabolism, or the breakdown of food things will actually have an increase in water. Whereas with loss, ventilation, okay, so we're talking about breathing through your skin, through sweat, and then excretion of waste. So we're talking about poop and pee, that, that's just the nature of the beast, So like when someone has, irritable bowel syndrome, or they have gastrointestinal issues and they end up having high levels of diarrhea and things like that. That's where people don't really understand that when they get severely dehydrated like that, and they're not putting water back in, plus they're not putting electrolytes back in, it's really, really, really a problem. And that's why people start to feel worse before they feel better, because they're not taking care of their rehydrating component. Okay. So in terms of water loss, we talked, going back over here, talking about sweat. Okay. But sweat is one of those things where we know is inevitable living in Florida, but it does vary per person. Obviously, it depends on body composition as one of them. But one of the things about sweat is that you can really pay attention to electrolyte balance. You can really pay attention to really what's going on with your body if you pay attention to, number one, how much you're sweating. All right. And then the color of the fluid that's going on. So ultimately, if you look at something, and I know sometimes it's a little bit difficult to see in the moment, but as you sweat as a person, what's happening is, especially if you're wearing clothes, when you start getting those white markings on everything, that's usually that loss of sodium and chloride, and it looks kind of has that white textury look to it, the grainy look. And that's because you're throwing out electrolytes. So we need to figure out how to rebalance that as best as possible. And that's usually under heavy load sweating. Doesn't mean it doesn't happen to everybody, but like if you're, just say you're outside and you're having a pickup basketball game or whatever, and then you're shooting around, playing a game, then you stop for a little while, your shirt starts to dry a little bit, sweat starts to slow down, and you start to notice the white markings. That's why it's always key to make sure that you have the right fluid with you, because you want to be able to get a little bit of electrolyte balance back in, because then you're going to retain fluid, so you don't get you don't have that hypohydration state or continue to start dehydrating yourself. Okay, so really kind of an interesting thing with sweating at that point. All right, and that's where we got into that sodium intake. That's why sometimes people shy away from things like Gatorade. They shy away from things that contain sodium, but we need that to provide the balance that we sometimes lose. Okay, so excuse me. When you look at everything, well, how do we get sodium into our system? Well, I mean, it's pretty straightforward with foods, but we know about fluids. But also, you can also take salt tablets, which sounds kind of crazy, but people do take those. And then there is sodium chloride supplementation. Now, distance runners and long duration training people, those are typically the people that are going to start experimenting with sodium chloride, because they want to hold on to and retain their fluid as much as possible without sweating it all out. So that's where we have to understand that part of it, is that you can supplement with it. There is some decent research with sodium chloride, and in terms of supplementation wise, and how, like, if you take it within a certain time frame before a competition, especially like we said, if it's like an Ironman or a marathon, things, long duration types of things, they can help. Okay, so that's how you get it through. All right, how do you lose it? Well, we already talked about urine and feces. We talked about sweat. All right, so that's where we have those. Well, we also need to understand that the kidneys do a job of excretion as well. So when the system understands that there's too much, the kidneys have to work harder to basically start to send out sodium so that it can be removed via waste byproduct. Okay, so in terms of intake, what are we getting? Processed foods. I mean, that's really the nature. So the nature of horribleness. I know it's not a word, but whatever. Really, when you look at majority of individuals across the country, 77% of most adults get their daily sodium intake from processed foods. So kind of scary. 11% is from table salt, like added. So what we're saying is added salt to foods. And then the other, as they said in the book, if I can type right, 12% of daily intake here. That comes from natural occurrence within foods that are, natural foods that have natural levels of salt in it. Okay. So what are we looking at in terms of, what's our intake? An adequate intake for someone under 50 is about 1,500 milligrams. Now, that's an adequate intake. That means that we should be having that much. Okay, that we should be having that much. And that's for proper balance of fluid, for proper nutrient intake, all right? Whereas the upper limit or the tolerable upper intake level or the UL of the DRIs that we always talked about in previous classes, those can be anywhere but, upwards of 2,300 milligrams. So what are we saying? Between 1,500 and 2,300 milligrams is somewhere in between. Now, you might hear dietitians throwing out things like 1,800 milligrams of sodium that are required in a day. Well, that fits in that mold. It fits in between that 1,500 to 2,300. Okay. So potassium, on the other hand, so again, trying to maintain balance here. Potassium is one of those ones that we need because if you remember going back to the composition, potassium is found at high levels within the cell. So where are we getting that from? Foods, beverages, or again, salt substitutes such as potassium chloride. All right. But potassium is found in high levels in naturally occurring products. So fruits, vegetables, whole grains, and then within milk. All right. So there's your intakes. Daily intake should be about 4,700 milligrams. But you're seeing in these stats right here, we're not getting those numbers. Average intakes for most people, we're not getting those numbers. Why? Simply because of the factor that we're not eating natural foods. The more natural foods we eat, the more potassium we get, and that's where it comes into play. But if you're not eating those, then you're not going to get those. All right, so 4,700 milligrams, I mean, if you're eating, and it doesn't mean you have to be a vegan. It just means that you have to be able to understand what you're putting into your body, okay? So, interestingly enough, though, you got to be careful with supplementation of potassium, and it's really interesting because you have hypo and hyper. So again, low and high, hyper or hypokalemia. So having too much potassium or not enough of it in the system. Now, these are really, really tricky because you want to be able to get enough in, but sometimes you end up going overboard because you don't really understand what the intake is supposed to be. And supplements are always, they always carry around high levels of something. They carry, 100% plus, meaning more of what that is out there. Okay. Whereas hypokalemia is below. Well, yeah, but look at there, diuretics, self-induced vomiting. Now we're talking about eating disorders and using things like laxatives or things like that that'll remove fluid from our system, but it's also going to remove potassium. So we can't have that. All right. And then excretion is regulated by the renal system. So again, working with kidneys to make sure that you're taking care of everything accordingly, and the body will understand. Well, no, we got to save some of that, so we're not going to excrete that. We're going to send that back to the system. Okay. So, excuse me. An adult. So typically, what are we talking about with? So we've kind of get past the electrolyte components of everything. Now let's get into, well, what do we got to do? What is it that we're going to do to help stave off, loss? We're going to try to get back things. So what we need to understand is that typically an average adult carries around about 2.8, so almost 3 liters of plasma. Okay, and because of that, factor, what ends up happening is you go through these changes throughout the day. Well, if you look here and it says if you have a 5% loss in fluid, okay, so if you look at the 2.8 liters, 5% loss is about 140 milliliters or about 5 ounces. So if you're losing 5 ounces of plasma through sweat or other compromising factors, then it's not really going to have too much of a drastic impact. When we start getting up into those 10% or higher, when you start losing 10% or higher of your fluid, that's when things can really become compromised. That's when, it doesn't mean it's going to shut down your cardiovascular system, let's just put it that way, but it's going to make your heart work differently. Okay, but the more fluid you lose, the more differently your heart works, so therefore you could lead to shutdown at some point if not taken care of. And then obviously what we're talking about for our sake in terms of performance is you're basically looking at, if you're starting to get up over 10%, performance declines. All right, so that's really comes to the part of the concern for that. So, with what are we looking at? With increases in sweating, we know that that's usually caused by typical increases in body temperature, but there's other factors too. Exercise intensity. So down here, environmental conditions. Well, look at the firefighter over here. Those are non-optimal environmental conditions that can become pretty tricky. Okay, now add what they're doing, which is pretty intense, moving hoses, throwing things around, climbing things, running, moving around constantly with the environmental conditions, and then the total high amount of clothing, and then of course the environmental conditions, it's hot as well. And then are they a trained individual? All of those are factors that are going to help them to either help them to be able to hold on to fluid, maybe not excrete as much in terms of sweat or other factors, or if they're not trained, it's going to be the opposite effect of that, where they're going to sweat more and cause massive problems on their system. So, again, these things are going to be the causes of potential hypohydration or dehydration concerns. All right. Now, if you look, I know this is talking about, rectal temperature, but it's the most consistent and prevalent way to determine internal temperature. But if you look what happens when you're actually replacing fluid accordingly, and what happens with your temperature. In a state where you're exercising and you're not taking in fluid, look what happens with your body temperature continues to rise, and that's where we start having this part where you're starting to have higher percentages of fluid loss that occur. So if you're looking at it from this standpoint now, fluid replacement is, so you're drinking fluids while you're doing whatever you're doing, can actually help you to maintain, even though it might be slightly higher. Okay. But we know with exercise, you have a naturally higher core temperature anyway, so there you go. So, what is it that we're looking at here? Well, sweat loss obviously is going to vary per person, but typically, you lose about 100 milliliters daily in a just kind of like consistent temperature. So a normal, regulated temperature with no exercise, so a sedentary condition. Now, when you start moving around, 1 to 2 liters per hour if you're exercising in high temperatures with protective clothing. So that's pretty intense there. Now you're starting to lose a lot. So if you're losing that much, well, then you're going to have to be able to find a way to put that back in, because you don't want to get, performance decrease because of that. Prolonged exercise greater than 2.5 liters per hour. Now you're talking about having to make sure you definitely do. All right. And then Don't forget too that in cold environments, that's another one that we kind of sometimes forget to think about. In cold environments, when you're breathing out, that's one way. And then even you probably have layers on, so you're still sweating. So you got to be very particular about that. But you're not going to need as much. But just understand you still have to replace fluid. All right. So, it is, when you're exercising, and we all do it. Everybody in this class does it. But we know that it's hard hard to get fluid in under specific circumstances. Now, if we're exercising and we're just training naturally, that that becomes a that becomes a little bit different, because of the fact that you're in the middle of doing something, and when you're in the middle of doing something, it's like the last thing you want to do sometimes is take in fluid, because it doesn't, it makes it feel funny inside of your stomach, or you feel like it's sloshing around, or whatever the excuse might be for that. So it is hard. So what you got to do is you got to make sure you got to get fluid in no matter what, because you don't want to end up like this lady over here that cashed out. All right. So also understand too that when you bring in fluids when you're exercising, like it says in the second part here, rates of fluid absorption are limited. Well, that's true, because blood flow is not necessarily going to, is not specifically going at high levels to the gastrointestinal system. So getting fluid to come into the system becomes a little bit more challenging, because majority of blood flow is going to the working muscles at that point and the brain. All right. So we also know that with fluid, we also know that exercise impedes gastric emptying. So what we're saying there is that we know that under exercise, we don't have that natural ability to want to go to the bathroom. Okay, and that's true for many cases. Think about a time maybe where you had to go to the bathroom at the start of your workout, and you started working out, and then you didn't really have that feeling anymore. So that can happen. So, and then understand too that, I mean, I know we're not in class right now, which is kind of disheartening, because we can't do this lab that I had planned for us. But it's been fairly warm outside too, which has been great. But losses of 2 to 7% of body weight is not uncommon, especially in difficult exercise situations. Some of you have done a lab before with me where we've done that, where you've gone outside in the heat, or you've trained and you try to see how much fluid you lose and what percentage of your body weight you actually lost. So it actually becomes pretty interesting when you start looking at it from that perspective. So what ends up happening though is that with a lack of, a loss of fluid, we end up with, an ability to lose body water, okay, which is called hypovolemia, okay, and that's usually with heavy sweating. That's what occurs. So when hypovolemia sets in, dehydration has an ability to set in, and therefore temperature starts to rise because of that. So keeping yourself hydrated, and I know it's hard to be in a euhydration state, but keeping yourself in a euhydrated state or close to it can help to avoid drastic changes in body temperature when it doesn't really need to be that way. Okay, so also when we look at it from the standpoint of making weight, this is why making weight can be really difficult. Because it really changes the chemistry of the system. All right, and when it changes the chemistry of your system in terms of proper water volume, which usually you don't have in a making weight situation, it's just going to make your core temperature want to boil, and then that's going to affect performance in its own right. So it can become really dangerous at that point as well. So in our situation here, we have to make sure that we don't end up with things like exercise-related muscle cramping. All right. How does that happen? I mean, there's a bunch of different ways to do it. They can be non-nutritional, which is kind of interesting. But we know typically that, sodium depletion, potassium depletion, dehydrative states, muscle fatigue, all those things come from these heat cramps. And then also, it's not something that's uncommon, but that's a telltale sign that things need to change really quickly, or you're going to start getting into some sort of heat exhaustion, or severe where it's heat stroke. So heat cramps are typically that one that kind of gives you the we got to make a change here. So, so how do we, to assess and monitor? Typically, the easiest way for us, I mean, there's some things here, 24-hour urine collections. Now, when you're starting to work with elite level athletes and things like that, typically isotope dilutions, plasma osmolarity, those types of things are going to be the things that are going to be data collection. So it's really one of those factors that comes into play where, we have to look at it from the standpoint of, is it really worth it? But if you're an elite athlete and you want to know what's going on during training or during specific situations, yeah, urine collections, isotope, where they're basically putting, isotope radiated isotopes through your system to kind of detect what's being diluted in your system, and then when you excrete it, how much you're excreting out. So, and you can kind of detect how much fluid's going through. All of those things are super expensive, but they may be worth it for someone who is like, making millions of dollars and needs to know more about their performance. But for most cases, we just do the urine analysis. And if we go to here, well, here's where we know we can be in some serious trouble or we can be in a good sense. Now, one of the things that we have to realize is that, clear urine is not always the greatest thing. It means that you can be overhydrated at that point. So that's where it can become a little bit tricky. But just understand that if there's a little yellow tint to it, that's actually more positive because that means that you're still in the right area. But I mean, what are we talking about? 1, 2, and 3. 1, 2, 3. Those are good levels. 6, 7, 8, not so good. Okay, 8 meaning that you're probably going to have something go on here, and then it's going to be a really big problem. So pay attention to your pee color is really what it comes down to. And when you wake up in the morning, you're in a hypohydrated state, and you've dehydrated overnight. So getting fluids into your system as soon as you can in the morning is it's pretty optimal because then you're setting yourself up for the day. Okay, so we were here. We talked about urine color, everything like that. It's really easy. And on top of that, with urine, you can detect the urine color. And then if you really wanted to see where you are, pH-wise, you can actually buy litmus strips, and you can see where you color up at that point and see how your pH balance is as well. All right. So in terms of how do we assess? Well, really, it's really this simple. 1 liter of acute, so we're talking about acute body weight changes. So 1 liter is about 1 kilo, roughly. Okay. So if we see that we have, 2 pound changes, that means that we lost maybe about about a liter of fluid. Okay. So we've got to pay attention to that. But again, it's not recommended for people with eating disorders or disordered eating simply because of the fact that, you're weighing yourself all the time, and that can become ingrained in their brain, and that's what you're trying to distract them from is weighing themselves because that can cause them to become more disordered at that point. Okay. I apologize for all the coughing. I don't have any water with me while I'm doing this, so interesting. So I guess that's what happens when you have coffee instead of water, and then you're talking about water. So, but again, really simply, we talked about urine color. Are you thirsty? And then weight loss. Those are just simple tricks to be able to do that. But what do we have to understand here? If you look at your W, your W, your U, and your T, your weight loss, your urine, and your thirst, if you have one that's a little bit off, it's not really too bad. Okay, that means that you're not in like a hypohydrated state. If you start getting to the point where you lose some weight and your urine has changed color, then it's likely that you're probably getting closer to, W being weight loss, U being urine color. You're pretty likely that you're going to be in a hypohydrated state, or urine color and thirst, or weight loss and thirst. All right, but if you have all three, you're probably basically you've lost weight, your urine color is pretty high, and you're thirsty. That's more like a very likely chance that you're not doing what you got to do. Okay, so again, pay attention to all those things, and you'll be okay. So you don't need to have the tens of thousands of dollars test to be able to tell you that you're hydrated or not. It's pretty simple. All right. So what do we need though? Well, really, it's individualized. That's really the key. The bottom line to this is everybody has an individualized plan, and by taking care of that, it's going to be necessary to keep that hydration set. All right. But also understand that there's going to be differing things for environmental conditions, and then obviously training because of stress stress loads that are put on you. Okay. So intake prior, what are we talking about? There's a couple of rules of thumb. All right, you can see all the stuff at the top, but the rules of thumb, about 5 to 10 milliliters per kilogram of body weight, 2 to 4 hours in time before exercise. And then 2 hours before, so leading up, 2 to 4, leading up to that, 2 hours, 3 to 5 milliliters per kilogram of body weight per, per that time frame. So you figure out how much you weigh in kilos, multiply it by 5 to 10. That's going to be how many, how much you're going to be able to have to take in at that point. And then 2 hours before, 3 to 5 milliliters at that point. So that's prior to, okay, and leading up to. But again, this is a way to individualize because it's based off of body weight, okay. So just like a quick rule of thumb. Then looking at here, these are kind of things that you're looking at in terms of, well, what are we, for pre-exercise, are we getting what we need? Do we really need to have carbohydrates at the time? Do we really need to have, are we looking at coffee at that time? But these are just different examples of what you could take in because we know that people do take in caffeine. We know that people do take in carbs, things like that. All right, and then going down through it, again, different examples of Gatorades, Powerades, not just fluids, but chews as well. So that's more for electrolyte purposes, things like that. All right. So during, what are we looking at to do during? Well, yeah, we want to get lost body water back. Okay. We want to try to slow dehydration. We want to make sure we avoid too much fluid. Okay, that can cause problems too because that can start pushing water out of the cells, and it's going to make you want to go to the bathroom, and that's going to be a problem. Okay, replacing sodium, we definitely want that. You want to make sure you get some carbs in there because during training, especially prolonged training, that's where things can come up as well. So what we look at in terms of intra, it really does go by how well it really goes by how well you're doing in terms of your sweat rate, your sweat composition, your durations of your training sessions. What are you wearing? What's the environment like? And around the country, it's going to change all of that because if the environment changes, clothing changes. All right. If it's too hot, it might change how long you train for, or you might do multiple bouts in a day. So you got a lot of things to plan on. But the ACSM, came out with a bunch of recommendations in conjunction with, I think it's the Dietitians of Canada, and then the Academy of Nutrition and Dietitians. These three came together to make these guidelines, so they're going to be followed for the next slide as well. But where do you start? Like if you're doing long distance, like marathon running and stuff like that, they say that 0.4 to 0.8 liters of fluid per hour. But again, it all depends on how hard you're training. But sometimes the lower level can sometimes be a good place to start because everybody has a different tolerance level for that. All right. Then again, examples of what you could do intra. Now, having carbohydrates in there can help because it's going to help with keeping muscle glycogen stores up. Okay. So, let's see. So afterwards, really the bottom line here, we can see all the goals that we have there, but really, and we kind of hit on a little bit of them a little bit. What's the strategy? Really, it's this simple down here. The basic strategy is for every kilo, 2.2 pounds, all right, you want to take in about 1.5 liters of fluid after, okay? But typically, this is where you need to make sure you weigh yourself before and you weigh yourself after. So for quick calculations here, just say that you lost, I don't know, just say that you weigh, 100 kilos, which is 100 kilos, which is 220 pounds, and you lost 3 kilos. That gives you 3. 3 kilos, multiply that by 2.2 pounds. That means technically you lost 6.5 pounds. Okay, so if you lost 3 kilos, what we're saying here is that, that's just kind of putting it into perspective, but you lost 3 kilos. Okay, well, we know that 3 kilos means that we have to figure out for every 1 kilo, you have to multiply that by 1.5 liters. That means that you need to, after you train, you need to start putting back 4.5 liters of fluid into your system. Well, what is that ultimately? Let's multiply that 4.5 by, because that's liters, by 33.8, because that's how many ounces are in a liter. That means that you have to take in 152 ounces after you train to reestablish hydration or get it close to it. Okay, well, how many gallons is that? Divided by 128, that's about 1.1 gallons. Okay, so about a gallon. So that's critical. Now, that's if you're going to be back up and doing it again tomorrow, this is really critical that you get that fluid back in. So you can see that people say, oh, you got to drink 8 cups of, 8 fluid ounces, 8 cups of 8 fluid ounces every day. It's like, no, I'm drinking double that post-training. So you get the idea, okay? We need to return back to normal functioning. Now, again, I know I went through those calculations really quick, but just kind of replay that and see kind of where I went with that and how, just understanding the conversion factors is really what's going to make the difference. Now, I know those off the top of my head, but just understand that you can always look that up as well. All right. So what are we looking for in terms of, what are we looking for? It really just depends. All right. Is the athlete generally euhydrate? Are they normal in terms of hydration? Well, we got to fix things if they're not. What are their goals prior to exercise? So we need to be, if their goals are, okay, then we know, and if they're euhydrated, then we know that water will be enough for them. We know that sometimes, though, they may need carbohydrates, so that may make a difference. So it just depends. And that's where you can determine how they're feeling and things like that. So a lot of these factors come into play. So a lot of times, if fluid is all that's necessary, there's really no reason to go out and add in sodium, to add in carbohydrates if necessary. If they're really not back to hydrated status, well, you got to figure that out, and that's where it's got to get tricky. It's going to get a little tricky. Okay. And then, here for after training, this can be a little bit interesting because these are all things that, hold on a second here. I do have a problem with a few of these. I didn't really read that part. There was a boost. So Boost is actually a meal replacement, and I don't buy into that. But some people take in chocolate milk, low-fat chocolate milk, so it's interesting to see. But just see what it contains. Actually, there is some potassium in there. Gatorade has I know that they do have a recovery shake now. But, just think about what it is that you're, if you're doing whey protein with other things, look at the sodium count, look at the potassium count, look at all the vitamin and mineral counts to see where you're at. Okay? And then from here, we look at action plans. What are the advantages of water? What are the advantages of sports beverages? What are the advantages of fruit juice, soft drinks? Okay, sometimes these things all and you can go through these on your own. I'm not going to go through them because they're pretty straightforward. But these are the advantages for these things. So water, yeah, sports beverages, yeah, but again, it's per person and how they can handle it. Whereas fruit juices, you got to figure out what it is that you're doing with that. But fruit juices can get a little tricky. If it's fruit juice, not like from concentrate, then you get the idea. Soft drinks and energy drinks, yeah, man, sometimes I just don't know why they're talking about those post-workout. But understand pre-workout, they can be for a benefit if needed. But soft drinks, I'm really having a hard time with on that. And then the disadvantages of water, disadvantages of sports beverages and fruit juices, right? They're all there. And then, for disadvantages of energy drinks and soft drinks, okay? So, and then moving through here, we're looking at, okay, well, if you have water, if you have if you look at water, carbs, calories, a 6% carbs beverage, that's basically like a Gatorade. This is what you're getting there, in terms of an 8-ounce container. So if you buy one of the bigger bottles at like 7-Eleven, that's 28 ounces. So you multiply all this by 3. All right. Gels, those are like the ones, the gel you actually squeeze out of the pack versus a large orange versus a banana and some water. So you can see where you're going with that, okay? So just kind of put things into perspective in terms of like what you're looking to do for your replacements, for your, for intra, for outside of, all right? So really, we have to, really we have to understand that, there is, when we're drinking things, it's not always just water. Okay, that's the key. We have to look at the energy content, the carb content, the electrolytes. Is there caffeine? Is there other compounds like, for example, beta alanine? Is that really, that's where you got to start looking into it on your own and researching like, well, does beta alanine affect hydration? And that's where it can become critical. Okay. And then lastly, they kind of sum up the chapter with talking about glycerol loading. So glycerol is actually a fat-like substance, and what it is, you can actually take it in what we call exogenously, so through water, or not water, through fluid or food stuff, and by doing that, it can change the osmolarity. We talked about that being hypotonic or hypertonic. What it does is, in a loading state, it can actually cause you to hold on to fluid versus get rid of it. So then you can basically pack fluid in versus pack more fluid in versus removing it in other ways. So the one thing I do see is that studies of effectiveness are mixed. I haven't really looked into glycerol loading that much, but it's actually something that's going to interest me as I read this to you all. But I don't like these right here. Temporary weight gain, that doesn't really bother me. It's the GI distress that bothers me, because if you're taking in high levels of glycerol, so it's again like it's a fatty substance, then ultimately, if it's going to cause GI upsetness, then you should not be using it unless you can tolerate it. But it doesn't make you feel good, especially if you're going to be training or competing, and that really becomes the concern there. All right, so that's your water and electrolytes. If you have any questions on this, please feel free to throw them back to me. But definitely, I put a little bit more lecture into these slides so that you can get a little bit more out of them, because I think sometimes the older slides didn't have enough in them. So I think this should help to kind of drive some things home. So again, any questions or concerns, throw it back to me. You guys all have my emails, my email address, so that you can get back to me, and then we'll go from there. So there'll be 2 more of these for the rest of the week. To go along with water and electrolytes, I believe, is vitamins and minerals. So pay attention for those as the week goes on. I hope everybody's staying safe, and take care, and get in contact with me with whatever you need. All right. Have a great day, everyone. See ya.